Okay, so we have two different conditions. One is warm summer day, and then one is winter day. And on different temperatures, the sound wave takes different time to reach to us. So our job is to find the temperature on the winter day. And so the temperature in summer day is given, which is 31 degrees Celsius. Now, to begin, we'll we'll have to look at table 12.1 to get the speed of sound in air at 0 degrees Celsius, which is 331 meters per second. Now, the reason we need this is because in section 12.1, you will see the relation between your temperature and the speed of sound at 0 degrees Celsius. So with change in, so this T is basically the temperature in Celsius. So with change in temperature, how your speed of sound changes, we can get that relation from this formula. Now, we are given two things. One is the summer day temperature, which is 31 degrees Celsius, and then one is the speed of sound in air at 0 degrees Celsius, which is 331 meters per second. Also, we know the time, right? So let's say um, let's say time for warm temperature. Let me write small t because that will be easier to understand. Sorry. So time on warm day is 4.8 seconds, and time on cold days is 5.2 seconds, right? Now, since the distance traveled on both days are equal, so we can easily write distance d equals to our velocity of sound or the speed of sound on warm day times the total time it takes on warm day, and that should be equal to velocity on cold day with time on cold day, right? Now, since we know this relation, we can easily use that over here, and we get something like the following. So 331 meters per second plus we have 0.6 factor, and then since it's 31 degrees Celsius, so we'll have 31 over here, and that's gonna be meters per second, and time is 4.8, so this multiplied by 4.8 seconds, and this should be equal to we follow the same thing, so it's going to be 331 meters per second plus 0.6 factor. Now we don't know the temperature, so that's an unknown. So let's denote that as T cold. So that's a big T and that's a little t, so don't get confused among them. But yeah, that's meter per second, and then time for cold days is 5.2 seconds, and if we solve for it, so yeah, you should try to solve this by on your own, but if we try to solve for it, we're basically solving for this unknown quantity, and we get something like T cold, which is equal to minus 14 degrees Celsius. Thank you.